Welcome to the Shikasa Boo Motor channel. This channel provides easy-to-understand explanations of car mechanisms. Today, more vehicle models are adopting mild hybrid systems with a 48 volts electrical architecture. Mercedes-Benz, Volkswagen, Audi, BMW, Volvo, Maserati, and so on. This video explains the structure and operation of mild hybrid systems, along with 48-volt electrical systems. Before diving into the details of mild hybrids, let's first review the classifications of hybrid systems. This channel simply refers to systems without external charging capability as hybrids. However, in this video, for the purpose of classification, these systems will be referred to as self-charging hybrids. Self-charging hybrids include three types: power split, series, and parallel. Power split systems are used by Toyota, Subaru, Ford, and Renault. Series hybrid systems are used by Honda and Nissan. However, Honda's system is not a purely series system. This channel offers videos that explain these hybrid systems in detail. If you're interested, be sure to check them out. You'll find the link in the description. There are not many examples of parallel hybrid systems being adopted as self-charging hybrids. Porsche and Toyota have adopted them in high-performance models, not for improving fuel efficiency. Plug-in hybrids, which allow external charging function, also includes three types, just like self-charging hybrids. Power split systems are used by Toyota and Ford. Series hybrid systems are used by Mitsubishi, but the system is not a purely series system. Parallel hybrid systems are adopted by many European manufacturers, including Mercedes-Benz, BMW, and Stellantis. These systems are capable of driving solely with the electric motor, and are classified as strong hybrids. On the other hand, hybrid systems that cannot drive solely with the electric motor are called mild hybrids. Mild hybrid vehicles use a parallel hybrid system. Furthermore, there are two types of mild hybrid systems, BSG and ISG. Please note, this classification is not universal, and there are some exceptions. As you know, engines are equipped with an alternator, which generates electricity to charge the battery and supply power to the electrical system, and a starter motor, which is an electric motor that cranks the engine during startup. This animation represents the simplest electric motor. If electricity flows through the motor, it rotates. If an external force is applied to rotate this motor, it generates electricity. In other words, it functions as a generator. Utilizing this principle, the ISG, integrated starter generator, allows the alternator to function as a starter motor as well. Mild hybrid systems operate the ISG, not only as a generator and a starter motor, but also as a drive motor during launch and acceleration to assist engine output. Because the ISG is driven by a belt, this system is referred to as a BSG, belt-driven ISG. Some automakers refer to hybrid systems that use a BSG as microhybrids. A major drawback of the BSG mild hybrid systems is that it uses a rubber belt for power transmission, which limits its ability to transmit high torque. For example, the BSG installed in the previous generation Mercedes-Benz E-Class W213 microhybrid model had an output of only 10 kilowatts and 38 newton meters, offering limited benefits in terms of fuel efficiency and acceleration. To overcome this weakness of BSG systems, a system has been adopted in which a high-output ISG is placed between the engine and the transmission. The system is arranged in the order of the engine, ISG, torque converter, and transmission. Let's take a look at how the mild hybrid operates. When starting the engine, the ISG operates as a starter motor and cranks the engine. After the engine starts, the ISG operates as a generator, charging the battery and supplying power to the electrical system. During launch and acceleration, the ISG operates as a drive motor, assisting the engine. During constant speed driving, the ISG operates as a generator, charging the battery and supplying power to the electrical system. During deceleration, the ISG operates as a generator, using its rotational resistance as braking force to slow down the vehicle. This operation is called regenerative braking. This system can use a higher output ISG than a BSG, but the existing 12-volt electrical system limits the ISG's output potential. We will talk a little about electricity. The flow of electricity can be explained by comparing it to the flow of water. Voltage is like the water level, and electric current is the amount of flowing water. The water level in a 48-volt electrical system is much higher than in a 12-volt system. Water flows from these two tanks to the water wheel. In the 48-volt system, water flows with greater force, making the water wheel spin faster, while in the 12-volt system, the water wheel spins more slowly. To make both water wheels spin at the same speed, the 12-volt system needs to use a larger pipe to flow a large amount of water. For this reason, when generating the same amount of energy, the water in the 12-volt system runs out quickly. In this way, even with the same amount of electrical energy as 12-volt systems, 48-volt systems allow the motor to generate higher output. As mentioned earlier, the BSG in the previous generation E-Class had an output of 10 kilowatts and 38 Newton meters. However, the ISG, which is positioned between the engine and transmission, in the current E-Class mild hybrid model, delivers 17 kilowatts and 205 Newton meters thanks to the 48-volt electrical system. The benefits of a 48-volt electrical system are not limited to hybrid systems. In recent years, electric power steering has become commonly used. For lightweight vehicles, a 12-volt electrical system is sufficient. But for heavier vehicles, there is a concern that rapid steering inputs could lead to a shortage of electrical power. Additionally, active anti-roll bars, which are used in some vehicle models, also require a significant amount of electrical power. Furthermore, if brake-by-wire systems are introduced in the future, the concern over power shortages will make a 48-volt electrical system necessary as well. However, the entire electrical system of a vehicle is not converted to 48 volts. Devices other than those requiring high power remain within the 12-volt electrical system. In a traditional 12-volt electrical system, the alternator generates 12-volt electricity, which charges the 12-volt battery, while also supplying power to the vehicle's electrical system. In a 48-volt mild hybrid, the ISG generates 48-volt electricity, which charges the 48-volt battery, while also supplying power to the ISG during operation as a drive motor, as well as to the electric power steering. Meanwhile, the 48-volt electricity is stepped down to 12 volts by the DC-DC converter and supplied to the 12-volt system. As an exception, the Tesla Cybertruck integrates all electrical systems into a 48-volt system. There is no doubt that Tesla's approach is more efficient, but given the well-established 12-volt electrical systems and the vast global supply chain, it is unlikely to spread easily. Thank you for watching. If you enjoyed this video, please consider subscribing to the channel. We'll see you in the next video.